Hey guys, welcome back to the channel Raghav Shukla, powered by Taxtron.in. In this video, we are going to understand the general properties of transition elements, not by mugging up points, but by real concepts and logic, exactly the way a classroom teacher explains. So let's start. What are transition elements? Transition elements are those elements in which the d orbitals are progressively filled in their atoms or icons. Because of these partially filled d orbitals, transition elements show some very special properties which are completely different from s block and p block elements. Now let us understand these properties one by one. Atomic and ionic radii across a transition series, the atomic radius decreases gradually from left to right. Why only gradually? Because when electrons are added, they enter the same d subshell, and d electrons are poor at shielding the nuclear charge. So the effective nuclear attraction increases slightly, pulling electrons closer. For ionic radii, higher oxidation state, smaller ionic size. Because more electrons are removed, increasing nuclear pull. That is why many transition metals have similar sizes and similar chemistry. Metallic character. All transition elements are true metals. They are hard, lustrous, good conductors of heat and electricity. This happens because both Ns and N-1, d electrons participate in metallic bonding, making the bonding very strong. That's why transition metals are widely used in tools, machines, and industries. Lattice structure. Most transition metals form close-packed crystal structures such as face-centered cubic, body-centered cubic, hexagonal close-packed. These structures allow maximum packing efficiency, which increases strength and stability. Density. Transition elements have very high density. Because their atomic mass is high, atomic size is small, atoms are tightly packed in the lattice. Density generally increases across the series and is maximum near the middle. Melting and boiling points. Transition metals usually have very high melting and boiling points. Reason: strong metallic bonding. Maximum number of unpaired d electrons in the middle of the series. Exception: zinc, cadmium, and mercury. They have completely filled d orbitals, so bonding is weaker. Enthalpy of atomization. Enthalpy of atomization is the energy required to convert a metal into gaseous atoms. Transition metals have high atomization enthalpy because strong interatomic forces. Involvement of both s and d electrons. It reaches maximum near the middle of the transition series. Ionization enthalpy. Ionization enthalpy of transition elements is higher than s block, lower than p block. Because they are smaller in size, d electrons shield poorly. The variation is irregular due to stability of half-filled and fully filled d orbitals. Oxidation states. This is a hallmark property of transition elements. They show variable oxidation states. Why? Energy gap between Ns and N-1, d orbitals is very small. So electrons can be lost from both. That's why elements like iron, manganese, and chromium show multiple oxidation states. Formation of colored icons. Most transition metal icons are colored. Reason: presence of partially filled d orbitals. d electronic transitions absorb visible light. The color depends on oxidation state. Ligands. Geometry of the complex. Thus, magnetic properties. Transition elements often show paramagnetism. Because they contain unpaired d electrons. More unpaired electrons, stronger paramagnetism. If all electrons are paired, the substance becomes diamagnetic. Catalytic properties. Many transition metals act as excellent catalysts. Why? Variable oxidation states. Ability to form intermediate complexes. Large surface area in finely divided form. That's why iron, nickel, platinum, and vanadium are widely used as catalysts. Complex formation. Transition metals readily form coordination compounds. Because small size, high charge density, availability of vacant d orbitals. This property is extremely important in biological systems and industrial chemistry. Interstitial compound formation. Small atoms like hydrogen, carbon, and nitrogen can occupy interstitial spaces in the metal lattice. This results in increased hardness, increased strength, retention of metallic conductivity. Example: steel. Alloy formation. Transition metals easily form alloys with other metals. Because similar atomic sizes, Same crystal structures. Alloys improve, strength corrosion resistance. Durability 15. Nature of halides, oxides, and sulfides. Halides are often covalent due to high polarizing power. Oxides show variable nature, basic, amphoteric, or acidic. Sulfides are generally stable and insoluble. This variability again arises due to variable oxidation states. So guys, this was a complete conceptual explanation of the general properties of transition elements. If this helped you understand chemistry deeply, like the video, subscribe to Raghav Shukla, and for more detailed notes and tools, visit taxtron.in. See you in the next concept. Fire.